In this video, we'll look at how strings are stored by computers. Remember that everything in a computer is stored as ones and zeros, so the strings must be stored as numbers. Each individual character in a string is stored as a number. This encoding is known as ASCII, which stands for American Standard Code for Information Interchange. The ASCII values are from 0 to 127, although the values from 128 to 255 have been used for other characters such as accident characters. The newer Unicode standard supports characters from other languages, but is backwards compatible with ASCII. There are different formats for storing Unicode strings, and the most common is known as UTF-8. In addition to characters from other languages, the Unicode standard defines values for characters such as the euro symbol and all the emoji characters you probably use in your text messages. Here are the ASCII values for a few characters. The codes for the letters are in alphabetical order, but there are different codes for uppercase and lowercase characters. The uppercase characters have lower ASCII values than the lowercase characters. Note the difference between the code for a lowercase letter and the same capital letter is 32. If you recall the base 2 encoding, you'll notice that means the bit for the 32 column is set for a lowercase character, but not for the uppercase character. Python has functions to convert between the character and its ASCII value. The built-in function ord takes a string of length 1 and returns the ASCII value for that character. Based on what we saw in the previous slide, we know that ord of A returns 97. The string you send the ord function must have length 1. If you call ord with a longer string, you will get an error. The chr function takes an integer and returns the corresponding character for that ASCII value. We'll look at this example from the book that shows how we can use the ASCII values to encrypt a string. Of course, this would be an easy encryption to break, as most computer scientists would recognize the ASCII value for the space. We also know that certain characters occur more often in English words, so even someone who didn't recognize this as ASCII codes could use frequency analysis and break the code. We'll start by asking the user to enter a string. In this program, we tell them the numbers are the ASCII and Unicode values for the characters. Remember, when you iterate over a string expression, the loop variable is assigned one character from the string each time through the loop. This also means the number of times the loop executes is the length of the string. Each time through the loop, ch is the next character from the string. We use the ord function to get the corresponding ASCII value and output. By using the end equals with a space, each ASCII value will be on the same line with a space between them. After the loop ends, we execute an empty print statement to move down a line in case there's anything else we are going to output. In this case, the program ends, but this also makes the status message that PyCharm shows appear lower in the console. We'll run this program and enter the string hello world. You can see the output shows the ASCII value for each character, including the space and punctuation. The obvious next program to write is one that takes the ASCII codes that this program produces and outputs the corresponding message. We need to learn a few more concepts before we can do that, so the next videos will cover those concepts first.